Can you break down indices for me?
Okay, stay with me. There are laws of indices, about 7 laws of indices. Each of them has a name attached to it for you to always remember them. The first one, we have the multiplication law, and it says where a base is raised to a power multiplying on the same base with a different power or even same power, what you do, you pick one base and then you add up the power. That is the first law. Now the second is division law. It is similar to that of the multiplication law, quite just a slight difference. We have a base raised to the power of something divided by same base raised to the power of another number, and then you pick one base, you subtract that of what? The power. The third law is called zero power law, where it states that every number or everything raised to the power of 0 is equal to 1. Example, we're having a raised to the power of 0 is what? 1. Even a million raised to the power of 0 is 1 as well. Now the fourth one, we have the negative power law. The negative power law talks about a base raised to a negative number. What you do, the negative serves as the inverse, 1 over, and then you bring every other thing down, your base and also your power. The fifth law talks about the product power law. The product power law. This is having a base in a bracket raised to the power of what? A number. What you do is you use the number to open up the word bracket, making it an times bn. an bn. That is the product power law. We go over to the sixth law. The sixth and the seventh law, they are alike, just a slight difference as well. We have the sixth law, we have the root power law. The root power law. Now, it says in this format where you have a base raised to the power of a fraction at the power level. Now, what you do is you make the denominator of your fraction takes the root of your base only. The denominator of your fraction takes the root of your base. And then the seventh one is closer to it. It is called fractional power law, where the first one, the numerator is insignificant with 1. But this case, we are having a number that is what? Significant. Now we still take it like this. The denominator takes the root of your power. Everything raised to the power of what? The numerator of your power. That is the 7th law of what? Indices. If you can be able to digest all 7 of these laws, indices become simpler. Okay, now we've learned about the 7 laws. Let's consider this example and apply these laws. Now I pick some questions that can help us, at least some questions can be able to touch 2 to 3 laws before we get to our final answers. Let's start the solution. The first one, we have 8 over 125 all raised to the power of 2 over 3. Now, one thing you should note is this particular power affects both the numerator and the denominator of your base, since they are all in brackets. Now, what we do is obey our fractional law. This is our fractional law, where the denominator of our power takes the roots of our base. If we are to apply this, this becomes the cube roots of 8 over 125 all raised to the power of 2. Having done that, if you punch your calculator, the third root of 8 is 2. Because 2 times 2 times 2 will give you what? 8. That is the third root of what? 8. 2. The third root of 125 is 5. Because 5 times 5 times 5 is going to give you what? 125. So 2 over 5 is the third root of 8 over 15. All raised to the power of 2. Now, this is still affecting the base. So this is like 2 raised to the power of 2 over 5 raised to the power of 2, making it 4 over 25. And that becomes our final answer. Okay, now the second example, we are having 2 raised to the power of 8, all raised to the power of 3 over 4. Now, to solve this, go back to our product power law, whereby we have our power multiplying all the base. Same thing is applicable to this. We are applying the product power law, where we have 2. Now the power multiply themselves, 8 times minus 3 over 4. And this becomes 4 in 4, 1, 4 in 8, 2. 2 times minus 3, minus 6. This becomes our final answer. You can go further and decide to obey the negative power law over here. What do we have to do? We have to what? Return it into this pattern. Your minus takes the inverse of 2 over 6. And 2 over 6 is also 1 over 64. Confirm that with your calculator. 1 over 2, 1 over 2 raised to the power of 6 is 1 over 24. That is the simplest form of the fraction. For the third one, we have the cube root of 27a raised to the power of minus 6. One common mistakes we make in mathematics is leaving our questions in a complex form where it's difficult to solve. As much as possible, try to simplify your question in the best possible way to what solve. If I was to solve this, the first thing that will come to my mind is this. I'll get rid of my cube roots. How do I do that? 27a raised to the power of minus 6, all raised to the power of 1 over 3. I got that from my roots power law, whereby it was formerly like this. I return it back to this format. Your roots, the root takes an inverse form or a fraction of your power. My cube roots turn towards my power, but in the inverse form, 1 over 3. Now I can simplify easily. In simplifying, this becomes 27. Remember, this is 1 term, this is 1 term. 27 raised to the power of 1 over 3 times a minus 6 times 1 over 3. This is the simpler form of it. Now this is still root 27 times 3 here 1, 3 here 2. We're having a minus 2. Cube root of 27 is 3, which is 3a minus 2. That becomes our final answer. I can still go down and say this is 1 over, or rather, this will be 3 over a raised to the power of 2. Negative power law. 3 times, this becomes 1 over a 2. 3 times 1, 3. And then a square times 1. A square times 1 will give me my a square. Okay, the fourth one, we are having 16 over 81 raised to the power of minus 3 over 4. Now, from the first, second, third, I've touched patterns of negative power law, product power law, root power law, fractional power law. We all know anything raised to the power of 0 is 1. Okay. Now, let's see this. The first thing to do, as I said, get your mathematics in a simpler method, in a simpler form, not a complex form, so you don't get problem solving. Now, the first thing to do, get rid of your minus. Whenever you're having a question like this, the first thing to apply is your negative power law. Change this to 1 over. Your minus becomes an inverse of everything that you're having here. 3 over 4. That is what you do first. Mathematically, this is also 81 over 16 raised to the power of 3 over 4. That is called flipping method. I have to take the third fraction up to the first fraction. Assuming there is a 2 here, I would have done 81 times 2, and then I will get something. So what you do, send this over. Just flip your fraction. When you do that, maintain your power. So this is actually this. This is same as this. Okay, now let's solve. We apply our fractional power law. This takes 4th root of 81 over 16, all raised to the power of 3. 4th root, my denominator of my power, takes the root of my base, 81 over 16, all raised to the power of 3, which is my numerator. Now, what do I do? The 4th root of 81 is 3. Why? Because 3 can be multiplied in 4 places to give you what? 81. The 4th root of 16 is 2. Why? Because 2 can be multiplied in 4 places to get you what? 16. That is how to check for the root of a particular what? Number. You don't need your calculator for that. All raised to the power of what? 3. Now you split. This is 3 raised to the power of 3 over 2 raised to the power of 3. This is 27 over 8, and that's our final answer. Now, we've gone through all of this. Let me give you a simple question from what we've done. It's simple already. Now, let me give you a simple question. You attempt this. We have 8 over 27 raised to the power of 2 over 3. Try this. I want to see your answer in the comment section. You can try this and then tell me your answer in the comment section. See you.